Okay, today we'll give you some explanation for quiz 7. Question 1, the multiple choice. Asking is the orbital diagram for ground state, electron configuration, ground state, nitrogen atom is which role? Give you several choice. So orbital diagram come from electron configuration. So to write electron configuration, we need this chart. So 1s, 2s, 2p, then 3s, 3p, 3d, 4s, 4p, 4d, 5s, 5p, 5d. Right? Fill in 1s orbital first, then followed by 2s, then 2p followed by 3s, then 3p followed by 4s. After 4s, start to fill in 3d, then 4p, then 5s. Use this chart, we can write electron configuration on and orbital diagram. For this question is for nitrogen, 7 electron. So 7 electron, the electron configuration should be 1s2, 2s2, 2p3. Right? So 1s or 1 orbital, we can draw a line or draw a box represent 1 orbital. 2s also 1 orbital. Either this way or this way. Then 2p, 3 orbitals. Or you can draw 3 box. Each orbital fill in 1 electron. This is Honda's rule tell us. So either this way or this way. So this way is rule 1. So correct answer is rule 1. Okay. Then question 2. Write electron configuration and draw orbital diagram for each of the following atoms. First is sulfur. From periodic table, we know sulfur has 16 electrons. Then, according to this chart, we can easily write electron configuration. So 1s first, 2 electrons. Then 2s, also 2 electrons. Then 2p could fill in 6 electrons because 2p is 3 orbitals. 3 orbitals, each orbital holds 2 electrons, so maximum 6. Then 3s, 1 orbital, 2 electrons. Then 3p again could fill in 6 electrons. But we don't have so many because the total 16. Here is 10, 12, then only 4 left. We cannot write 6 in 3p. So only 4 left. 3p4. Okay. Then we write electron the orbital diagram right underneath electron configuration. So draw 1 box underneath 1s. 2s also 1 box, 1 orbital. 2p, 3 orbitals, 6 electrons. Each orbital holds 2 electrons in opposite spin direction. Then 3s is a 1 orbital, 2 electrons. 3p, 3 orbitals, 4 electrons. According to Honda's rule, so fill in 1 electron first. Then the last one you can fill in any of these 2, any one of these 3. Sorry. So So that must be opposite spin direction. You can fill in last one in this or this or this, or fine. Okay. Then B, R. So R 26 electron. So we can write electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, only 6 left. We cannot write a 10. 3d maximum can hold a 10 electron, but up to here only 6 left. So now we write the electron configuration 1s, 1 orbital, 2 electron, 2s, 1 orbital, 2 electron, 2p, three orbitals hold 6 electron, each orbital hold 2. 3s, 1 orbital, 2 electron. 3p, again, 3 orbitals, then 4s, 1 orbital, 3d, 5 orbitals, fill in 1 electron first in each orbital. Then last one, you can fill in any one of these 5, but it must be in opposite spin direction. Okay. This is R. Then C is calcium. 20 electron. So we can write the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, then 4s2. Total 20 electron. Then orbital diagram, 1s is 1 orbital, 2s also 1 orbital, 2 electron. 2p, 3 orbitals, 6 electron. There are 2 electrons in each orbital in opposite spin direction. 3s, 1 orbitals, 1 orbital. 3p, 3 orbitals. There are 2 electrons in each orbital with opposite spin direction. 4s, 1 orbital, 2 electrons in opposite spin direction. Okay. This is a C. Okay. D, copper. 29 electron. So we can still use this charge, right? The electron configuration 1s2, 2s2, 2p6, then 3s2, 3p6, then 4s2 up to here, 20, then 9 left in D. So whenever you see D9, you need to think about, or 1 from its neighbor S becomes D10. Because D10 full fill more stable. This is a special case. Another special case is D4. So whenever you say D4, then think about for 1 for its neighbor S becomes D5. That is a half fill, also more stable. Then we can write orbital diagram. 1s is a 1 orbital, 2 electron. 2s also 1 orbital, 2 electron. 2p, 3 orbitals, 2 electrons in each orbital in opposite spin direction. 3s, 1 orbital. 3p, 3 orbitals. 4s, only 1 orbital, only 1 electron in 4s. 3d, 5 orbitals, 10 electron. So full field, more stable. So again, this is example of special case. Whenever you see D9, think about for 1 for its neighbor S orbital becomes D10. It's a full field, more stable. Another special case is whenever you see D4, think about it becomes D5 for 1 for its neighbor S. So D5 is half field, also more stable. Then question 3. Here is 2 energy level of a hypothetical atom. So D2 is negative 12 times 10 to the negative 19th power joule. E1 is negative 18 times 10 to the negative 19th power joule. Then question 8 asks you what is the energy in joule a photon must have in order to excite electron from E1 to E2. So electron initially in E1 orbital energy is negative 18 times 10 to the negative 19th power joule. Want to excite it or promote it to E2 energy level. How much energy needed? Of course, the energy difference between these two, right? So the energy needed is the energy difference between these two. So since from E1 to E2, so E2 is final, always final minus initial. Negative 12 minus negative 18 is 6 times 10 to the negative 19th power joule. This is the energy needed. Question B asks you, what is the wavelength of the photon needed to excite electron from E1 to E2? Excite electron from E1 to E2. The energy comes from a light. The light consists of a photon. Right? So energy of one photon is h nu. Right? So here asks you wavelengths. So we're going to need to use a wavelength times frequency equals to c. So frequency equal to c divided by wavelength. So h times c divided by wavelength, right? Then your wavelength lambda will be h times c divided by e. So switch e with lambda. So h is a Planck constant. I provided you value on the top of this sheet. 6.63 times 10 to the negative 34 joule second. C, light speed, also provided you value in the top of this sheet. 3 times 10 to the 8th power meter per second. E, we just calculate. So 6 times 10 to the negative 19. We find joule, cancel this joule. Second, cancel this per second. Left over meter. So use the calculator, figure out 6.63 times 3 divided by 6. This is very easy. 6.63 times 3 divided by 6. The answer will be 3.351 times Exponent, don't put it in the calculator. Exponent multiplication is plus, division is minus, right? So negative 34 plus 8 minus negative 19. Then together will be negative 7. Unit is meter. Okay. You can keep this as your final answer because I didn't specify in meter or nanometer. But if you want to convert to nanometer, just times 10 to the 9th power. So 9 minus 7 is 2. 2, we can move 2 decimal place here. Becomes 331.5 nanometer. You don't have to do this because I didn't specify wavelength in nanometer. So you can keep it in meter. This is question 3. Then question 4. What is the wavelength of light having frequency 3.6 times 10 to the 10th power hertz? So tell us frequency, ask you wavelength. So we're going to use their relationship. Wavelength times frequency equals to light speed c. So wavelength should be c divided by frequency. C is 3 times 10 to the 8th power meter per second light speed. I provided the value here. The new tell you frequency is 3.6 times 10 to the 10th power hertz. Hertz cancel this per second left over meter. So use calculator 3 divided by 3.6. This is 0.833. Exponent 8 minus 10, negative 2. Unit is meter. Since this is less than 1, so scientific notation requires this number is larger than 1, smaller than 10, right? We just move 1 decimal place. 8.33 times 10 to the negative 3. This is A. B. Here you wavelength 350 nanometer. What is the frequency? So this time is the opposite. Here you wavelength, ask you frequency. So mu equal to c divided by lambda. Okay, c. What is the value here in the top of this sheet? 3 times 10 to the 8th power meter per second. Wavelength here tell you is 350 nanometer. So we need to convert this into meter because here is meter. We need to convert this into meter. 1 nanometer, 10 to the negative 9th power meter. So nanometer cancelled, the meter cancelled this meter, left over per second, which is hertz. This is the unit we want. So use calculator 3 divided by 350, which is 0.00857. 10 to the 8th power divided by 10 to the negative 9. So 8 minus negative 9, which is 17. This too small. Move 3 decimal place becomes larger than 1, smaller than 10, right? Then you move 3 decimal place. Then you need to reduce the 3 here. It's 14. Unit is hertz. Per second is hertz. Last question 5. Actually, this question number we don't need this. Last question 5. A asks you how many electrons can be placed in the 4D subshell. D always 5 orbitals, right? How many electrons can be placed in 5 orbitals? Of course 10, because each orbital can place 2. Then total could place 10 electrons. B asks you how many orbitals in a P subshell. P sub here always 3 octets, right? That's it for the quiz 7. Okay. Overall, quiz 7 pretty good. We have several students made 20 out of 20. Okay. For those failed, you need spend some time after class.